Hello, everybody. Hello, RSA community. It's really my pleasure to be here. I want to talk to you about a really important topic in the world of information security that I don't think is addressed really well overall, and that's about designing access control. I want you to understand my perspective of this topic. I tend to teach software developers. This presentation is directed at you, the software developer, who's trying to build enterprise software and determine how you're going to build access control into that piece of software. The decisions that you make early on are going to be extremely hard to change once you're deep into an application's lifecycle. So let's talk about this. What does access control mean? And how should we be building as a developer so access control design is future-proof for all the different requirements that show up in the world of enterprise security and development? By the way, everyone, who am I? My name is Jim Manico. I'll be your presenter today. I'm an educator in the world of application security, and I'm an author. And my focus is describing to developers how to build secure software. I'm a student in the area as well. Please don't hack without legal permission, everybody. There's a legal warning I've been asked to put up on a regular basis. You're going to learn a couple hacking techniques along the way. Please use those techniques responsibly in the modern era. So we're going to look at role-based access control and talk about why it's problematic. And I don't mean the role-based access control as a design mechanism. My concern is when you're using role-based access control as a policy enforcement point. We'll explain that in just a few minutes. The goal here is to look at different attacks on access control, which are straightforward, and also some anti-patterns of design in your software that you want to avoid when doing access control. We'll also look at some best practices, which is really about shifting from a role-based mechanism to a capabilities model, which is going to be future-proofing and future-proof your software in terms of adding new access control requirements that almost always tend to come later in the project. And yeah, claims-based access control is really the answer in the modern era. So let's start by looking at the negative, unfortunately. Let's look at the anti-patterns that show up in software, and then we'll look at a solution set for design. And by the way, when I typically talk about building software, I like to get concrete about very specific frameworks and languages. When we look at access control in this topic, it's a little bit of a step back. I just want to get across a couple design principles that should be universal for all developers building secure software. All right, so here's the anti-patterns I care about. Number one, the number one pattern that you need to avoid in software is hard coding roles in your code. And every language and framework not only supports this, they often encourage it. It's a way to get started easily with access control as a developer, and you get it working right away, but it's fragile, it has lots of problems we'll look at in this presentation. I'm also concerned about access control that's not centralized, that's hard-coded all throughout your software, as opposed to having a centralized enforcement point across the entire piece of software. I'm also worried about the wrong data driving access control decisions, like untrusted data that an attacker could taint in some way. We should be cautious around what kind of access control decisions untainted data or tainted data could drive. Also, I'm worried about access control that's open by default. And what I mean by open by default is if something goes wrong in the software in some way, that access is granted. When there's a failure in your access control logic, we want to deny right away, of course. I'm also worried about the lack of addressing horizontal access control. And I really think of this as one of the real big ones here. Because what do I mean by horizontal access control? I'm talking about data-specific access control. It's rarely addressed well in frameworks even. It's something we have to custom code ourselves frequently, and it's very difficult to get that right. And so it's also something that roles do not address at all. And so these are some of the issues we're going to go over in this presentation. So what's the problem here, right? The problem here is that a lot of our frameworks support access control out of the box that's role-based, and we're encouraged to use it. And the critical things we need are big multi-tenancy, having different rules for different customers that use our software, and data-specific access control When I'm trying to control access to an individual piece of data or an individual row in a database, and that kind of granular access control is almost never dealt well within our frameworks and software. There's other issues like workflows and business logic that we'll talk about as well. But these are the problems that we see in modern frameworks, and softwares are often forced to go down a bad path. So let's take a look at this a little more carefully. When I'm talking about role-based access control, I'm not saying that roles are bad. What I am saying, though, is hard coding roles into your software, basically using roles as a policy enforcement point, that's the problem. Because now what I've done here, I'm saying if the user is a manager or if they're an administrator or if they're an editor, then let them execute this action. And I've now coupled the policy into the source code. This code is my policy. Imagine millions of lines of software written this way. One of the characteristics of secure software is its auditability, is the ability for an auditor to determine the security properties of the software. And if I hand you like millions of lines of code that's all have hard-coded roles and checks throughout the code base like this, how does the auditor verify what your policy is? Oh, the auditor can just go through your 5 million lines of code and deduce policy checks. Fail. That's not really auditable. It's not provable, and it's extraordinarily fragile, especially at scale. So that's the problem. Let's go into a few more things that goes wrong with role-based access control. First of all, again, it makes the proving of software difficult for auditing or QA purposes. I now have to literally dig through millions of lines of code looking for all the role checks to deduce your policy. It's a non-starter at best. Two, anytime I have to change policy, I need to be pushing code. And that limits the flexibility I have with driving policy in a piece of software. And again, let's bring this up yet again. There's no multi-tenancy. Now, multi-tenancy, at least in my world, it's a super important characteristic of service-based enterprise software, where I'm producing an API that I want many different companies to purchase from me in some way or use my service in some way. Customer A may be like, this report is for admins only. Customer B might be, that same report is for managers, administrators, and my other leads. And so how do you handle this? You have one feature, one report, and two customers who each want a different policy. If you're hard coding roles, your ability to achieve multi-tenancy goes away fast. You can do stuff like forking the code base or putting switches in your code for every customer, and that's a fail. And also, hard-coded roles don't address the critical, and these are simple problems, horizontal access control. Even something as simple as ownership, where this data is owned by me. Only I, the owner, should be able to look at that data. Role-based access control, when it's hard-coded, does not address these requirements. And you end up seeing developers dealing with these in customized ways, dealing with by hand on a feature-by-feature basis. It's a fail, in my opinion. And this is not automatic. You have to hand code this as well, even worse. So every feature of my app, I have to hand code the access control check. There's got to be a better way, and there is. The real answer to this problem of how frameworks hard code roles, which is a very immature access control design, and again, let me clarify, it's not roles that are evil. It's hard coded roles that are super inflexible and tend to lead to poor access control that doesn't satisfy requirements of modern enterprise software. So let's get to best practices. The first, and by the way, this presentation made an interest. If you're not a developer designing access control, you might not be super interested in this topic, and that's okay. I want to give you one tip. If you walk away with one tip, then it's going to help you in the future if you're part of designing access control for a software, and that's don't enforce access control by a role. Stop doing that. In the actual point of enforcement, it should be the name of your activity or a feature And this is called a different thing by different frameworks. So the Java world calls it permission-based security. .NET calls it capabilities. The US federal government calls it attribute-based access control. There's no standardized name for this thought. So I think about it as, when I am actually going to enforce access control in my software, I want to do it by the activity name itself. This seems really subtle, but it's not. So I'm saying, if the user has access to edit the article, let them do it. Please note, this check has nothing to do with the user themselves and the user metadata. It's just checking what feature is being executed. And the good thing about this is I can code it once and never have to touch it again, right? And so the other good thing is it implies a policy is centralized under the has access function in some way or in a database. It implies policy is persisted in some way. Since this check alone is not enough, I need to dig in the has access function. I need to look up a data store and look up the policy before I make a decision. So this is the heart of modern access control. It's hard coding the name of the feature or the permission as opposed to the role. Now let's see what we can do with this. This just gets really powerful fast. Now, it's powerful, but it does take a lot of design work up front to get right. That's why a lot of us as developers, we can just start hard coding roles and they work right away. To do attribute, activity, permission, capabilities-based access control, that's a bit trickier. We have to really design a database and similar up front to make this work. So again, I'm trying to avoid this. Here's a little video game world, Star Wars world, right? If the user is a Jedi, if the user is a Sith Lord, if the user is a Jedi-killing cyborg, then let them wield the lightsaber. This is an example of role-based access control where every time I have to add a new character type to the game, I got to change the code. Every time I want to change this policy, I have to change this code in many locations in code. By the way, RSA, I have a license for this image. I am using legally licensed Disney imagery from the Lego Disney World with very cheap license. Yoda license, very expensive. Yoda Lego license, very cheap. So this is a license. I'm not messing with Disney. We all love Disney. Let's move on. Okay, so let's go deeper into this. So now that same role-based check, is the user a Sith? Is the user a Jedi? And what kind of user is it? We don't care about that. We just care if the user is permitted to wield a lightsaber, and that's it. That's another example of what I mean by an activity check or a claims check. Let's go deeper into it. We're going to go deeper. We also want to implement data contextual access control, data specific access control in some kind of standardized way. Almost never see this as an auditor. So the problem is the web app needs access to an individual piece of data. And it's not just the web app here. It's the user, a specific user needs access to a specific data that doesn't fit into grouping very well. So my check in code should look like this. In this check, I'm going to see if the user in this game can pilot a vehicle. So I first get the vehicle they're trying to pilot, and I cast that to an integer. So I know I have a real ID for that item. Then I say, if the user is permitted to drive Winnebago of a certain number, they're allowed to do it. The point of this enforcement check is once I code like this, right? Once I'm coding like this, I can handle completely different flexibility and different policy for 1,000 different customers without ever touching this code ever again. Now that's a really big deal for those of you who've supported like APIs and services. You have to support multiple customers and multiple access control designs. And Ulrich is asking, will you make the slides available? Ulrich, of course I will. Who would ever do a presentation and not give out the slides? That's horrible. Ulrich, I promise you, you'll get the slides later on. Let's move on. So now, I typically say never use your framework's access control because they're never granular enough. There are examples in the last couple of years of frameworks that are starting to get this right. And Ron Paris from SNCC introduced me to Cancan's access control design, which is really robust. Like I can check, is a user allowed to view, set the policy to allow users to view all public posts, right? So allow a user to view any post that's classify as public. Pretty straightforward. Enforce that through policy and code. So my enforcement check is, can the user view a post? That's another kind of claims based, right? I'm not asking about the user's role. I'm not asking about metadata about the user. I'm just saying, can I view a certain post? Capability all the way. And this is why Cancan really lit up in my world as an application security educator, because now I can add ownership and complexity here. I can allow the user to edit or delete a post, but only if the user of the post is the author is the current user. I can't do this with roles, not in any kind of reasonable, scalable, provable way, not an audible way. So the power of this is dramatic. When you shift from hard coding roles, which is limited, to hard coding claims and features, which is relatively unlimited in the feature potential for the future. In the world of Java, I've seen Oak. This is the closest in my world of a framework that gets it right. But the problem is when you're buying into the Oak framework, which I think is outstanding, there's like 20 database tables you have to deliver in your schema. I don't know about you. I don't want products adding to my schema. I'm very specific how I build my schemas in third normal form, tactical denormalization. I have all my tricks like most DBAs do. And when someone says you got to use our tables, that's no for me. So I like the frameworks out there, but they're usually the customization to retrofit them in my world is super expensive and time consuming, which is why almost all the time I'm building this myself. And who wants the era of like logging in and authentication is stop building authentication yourself. Use an identity provider, please. But with access control, other than a few good examples like Cancan and a few others, I recommend you build it yourself. If you like these database tables that you must use with Oak, it's worth considering. The point I'm trying to make is there's all these products and services in the market for developers where you buy a solution that does access control for you. And in my experience, those solutions for not access control for the enterprise, but access control for a piece of software, which I have to design, most of the products out there handle the easy problems. They don't handle the problems like multi-tenancy. They don't handle the problems like data contextual. So I really recommend building your own access control for the enterprise. And most of my customers, most big companies I see that do this, that's exactly what they're doing. It's hard for access control products at the individual app level to be of service. They're hard to retrofit in and often don't have the fancy features I need. Now, if I go back in time, though, look at the beginning of .NET, as early as like .NET 1. .NET was one of the early leaders in claims-based access control. It's more tricky to use. Not every developer uses it. But I want to point out that .NET had their act together for a long time. Like I'm claiming authorized for the permission can wield lightsaber. If so, then go. This is not about the user's role. This is not about who the user is. It's about, are they allowed to run this particular feature? And I can code like this and never change that code ever again. And that's a big deal. So I want to talk about a really basic database schema to drive complicated access control. This is a good beginning. Beyond this, I would group every category. And my roles, what you think of roles in a traditional role system, in my world, they're groups of users. So let's take a look at this data set, like all filled out here. So I have all my permissions for this game: wield lightsaber, drive starship, the Force Ghost power, and drive starship. This is me as a developer configuring the policy of my application, right? I haven't granted anyone any entitlements yet. I haven't entitled anyone to do anything in my system. I'm just setting up the metadata for all these features here, right? And so let me fix this real. So what's going on here, right? What's going on here? So I have wield lightsaber that doesn't require a data check. That means if you can wield a lightsaber, anyone can do it. I'm sorry, if you have the wield lightsaber entitlement, you can wield any lightsaber you want. There's drive starship that does require a data check of type 10, type starship. There's the force ghost power. That implies if you got the power, you can use it. That's great. Then there's drive starship. Please note from a different customer. They do not require a data check. So this customer who's using this video game, 25, you can drive a starship only if you have the right to drive that starship granted to you. And for this other customer, same service, I can say drive starship which doesn't require a data check. So this implies if you can drive a starship for this customer, you can drive them all. And if you can drive a starship for that customer, you only can drive the ones you've been granted access to. So the point I'm trying to make here is now I have one system, one software, one API, one database, and I can support as many flexible access control requirements as is thrown at me, as long as I start by hard coding the name of the feature, the capability, as opposed to the role, right? And so what do I have here? I also have, now let's grant some entitlements. Let's allow users to do things. User one, Luke Skywalker. Hey, Luke can do 26. Force Ghost from one of the past movies, right? So that's great. So Luke can do Force Ghost, and we're done. So user one can also do 25. User one, Luke, he can do 25. Drive Starship. That does require a data check. So we see that user one, user one, Luke Skywalker, he can 25. Drive Starship requires a data check of type 10. That's a Starship, and he can now drive Starship. 1138 is the vehicle number he can now drive. So I've done a very granular grant. I have allowed one user to pilot one vehicle, and good luck doing that with access control. Now, with good luck doing that with role-based access control. You can do stuff like if the user is allowed to drive a role which is vehicle _ 1138, then you get in a unique role for every piece of data. That leads to role explosion. Now I have tens of thousands of roles in my system, and unless you're using really heavy automation, that's not provable from a security point of view. Now I have groups down here. Group 5 is a group Jedi, and they all get to 24. So what's that? That's wield lightsaber. Any Jedi can wield lightsaber. That's either an old school role during software migration to a new mechanism, or it's just a group which looks like a role name. So I could even name that role ID, and that it looks like a group. It's in the data structure as a group, and in my configuration layer, I can make it look like a role, just so it's easier to configure the system. So I digress. So the whole point I'm trying to make here is when you hard code to the capability, and with this kind of custom database, not that difficult. On your own, in a couple days of coding, you can begin an infrastructure to handle any requirement thrown at you in the world of enterprise access control for the software that you're building today, right? Let's look at a few more best practices, right? And so I also want to make sure that I'm building a centralized mechanism. There we go, centralized mechanism. And this is a comment against the hard-coded role-based mechanism that's so common, where I'm hard-coding my policy in every individual feature. That's the opposite of being centralized, right? So let's keep charging here. Now, what I mean by this is this right here. I'm going to have an access control service that has two basic primitives: is authorized and assert authorized. And when do I use each? Because if I'm in code doing an access control check, and I'm saying, is a user authorized to run this function constant? Like, is user authorized to wield lightsaber for our last example? And that check is true or false. And if the user doesn't have access to wield the lightsaber, I return a false and I move on with my life. Now, the other function, assert authorized. Suppose I'm saying assert authorized, the user can wield the lightsaber. If that returns a false, then that function will throw an access control exception and signal to me as the software author that we're under attack. Now, why is that? Why do I use assert, and when do I use assert, and when do I use is authorized? Let me explain this. In the presentation layer, I may choose whether or not to display a link. So I'm saying, is a user authorized to actually view the admin panel? And if so, I show them that link. And if not, I just don't show them the link and I don't sound the alarm. It's no big deal. It's an access control failure. Don't show the user that data and move on. In other situations, I'm going to be more assertive. I'm going to say, in this case, I'm going to say assert authorized for delete user. The point of this is I'm on the server now. I'm in the controller of my application. Someone's trying to delete a user with that action, and I'm going to check if they're allowed to do it. If they're not allowed to do it, then how do they even try to do this in the first place? They either bypass the user interface, there is a bug in my code, or I'm under attack in some way. So server-side features, I'm asserting you better have the right access control to even make this check. And if there's a problem, I sound the alarm. In the presentation layer, it's no big deal. If the failure is there, I just don't show the data or the link, and I move on. Right? Let's look at some more best practices here. Another big one I want to look at is the idea of we want to make sure all requests are authorized. So I like to use in my own development a pattern called the command pattern. The command pattern says that every feature should basically be its own unique endpoint, right? I'm not going to have one endpoint that's overloaded for a lot of different features based on the parameter. So command pattern, one endpoint per feature, step one. And if that's in play, then I can have in the database what the name of each feature is. And when someone makes a request to my system, I look up what feature they're running and check out the policy. With these pieces in play, I can now do access control in a filter. So I force every single request to go through my access control checking layer. It's going to be much more robust than, again, hand coding it into each individual feature. Here's an example of how to do that as well. So in this case, I have a URL to read a message from a messaging system, and the user can tamper with that ID easily, right? They have view message for a certain message ID. They tamper with the ID, and they can see different messages. And there's the query in the database. Select star from messages where the message ID is a certain number. This is trivial to tamper with. The world of security, web security, they call this indirect object reference. I don't like that name. I call it horizontal access control flaw is more how I see it, for whatever. Now, when I'm handed this problem, I ask myself, look at the code, is this feature meant to establish ownership? Should only owners of a message be able to see that message? In this case, the answer is yes. So I can do this. I can say, select star from messages where the message ID is a certain number and the owner of that message is the actual logged in user ID, which I get from a trusted source, like a session or from the JSON web token whose signature is valid on my server. And now I can grab that user ID and use that to establish ownership. When I can get away with this, I can. And as a side note, I'm often stopped from doing this because the feature says, if the user is the owner, let them see the message. Or if this is administrator, let them see the message. And it gets complicated. So my take on this is never overload features like that. If you have the ability for an admin to see all messages, please put that in a separate application that's on your firewall, that's on your intranet with extra controls, and go out of your way to lock that down in an admin level app with stronger authentication, more control. I try to keep all administrative features out of my main application when I can get away with it. It's a great isolation. It's very, very helpful from a security point of view. Let's look at some more best practices here. Let's also talk about just a few basics. Deny by default and fail securely. Deny by default is saying, if there's a flaw in my code and there's like an exception thrown, then fail out. Don't let me set, one of the tricks I can do as a pen tester is I'll look at metadata going into your app that might drive access control and delete it from the request. It would typically return an empty string if there was no value in a web parameter. But if I delete it, it returns a null in some languages, which causes an exception that's not expected by the developer that causes access control to fail in a way that I hope it should fail in a way that doesn't grant access. That's also what we also mean by fail securely as well. let me charge on here. Now, access control is complicated. This is a brief presentation to hopefully give you some ideas as you go through application security type needs in software. But I really would recommend that you go take a look at a good standard. And actually, let me come back to that in a moment. Forgive me for a second. Let me do a few more best practices first for you. A few more best practices. But I want to talk about how to standardize this, and then we're almost done, folks. So thanks for being here with me. So where am I going? We're all over the place. We're crazy. We got this, though. Server-side trusted data is what should drive access control decisions. In my youth, I was auditing a bank, and they handed me a cookie that described my role. And just by manipulating that cookie, which is a text file in your browser, I could elevate my access. This is the problem, the core story in my world that I'm trying to avoid. So the way I think it through like this, right? Request data should never drive a policy decision. Request data can drive what I'm changing or what data is being changed, but the policy should all be on the back end. And we never want to make access control decisions in JavaScript. That's view source. So I can see all those checks. We never want to make access control policy decisions based only on request data, like a hidden field, a form parameter, anything else in the request. And we never want to depend on the order of values from a browser or a web client. We can't trust those in any way. So let me show you this in one more way. So this is good data to drive access control policy, right? First of all, an active session ID. Then I grab the identity ID of what the user is acting on. I look at the modified data, and I look at the JSON web token for permissions or the server-side permissions of a session model. And these are things that from the client I need. Everything else should be server-side, right? It's like the feature being accessed. I should look up that policy, the policy itself, the actual rules that we give to a user about access, all that stuff should all be server-side and only server-side. All right, let's look at some more. We're looking at best practices. What's the last one here? Oh, yeah. The last best practice here is, hang on, almost there. There we go. Sorry, folks. Okay, we know that server-side data should control access control decisions. We know that already. There we go. Enforce only valid workflow paths. This is another area of access control that traditional role-based access control is just not going to solve. This is another area where we need to do something special beyond the norm. This is also an area where no framework on the planet that I know of will address this problem of workflow security. Here's what I mean by this, right? So I'm going to buy something in a digital shopping cart. I start by choosing the data package. Then I'm going to customize the package to my liking. Then I'm going to make a payment. Then I'm going to download the data. So the question is, if you're the threat agent, if you're the attacker, what step are you going to skip? Just skip payment, of course. Go choose data, customize package, and then download it. You would be shocked how much software is vulnerable to problems of this nature. The download data feature should, of course, check that the payment is complete, that everything else is done before we allow the actual product to be shipped or the data that's being purchased to be downloaded. And the thing is, again, standard access control does not address this. Also, the tools that we depend on for security analysis, like static analysis, dynamic analysis, third-party library scanning, almost never addresses this problem. So keep an eye on your workflows, everybody. Keep an eye on those workflows. Let's charge on here. We're looking at best practices. Be able to change a user's entitlements in real time and do grouping. So for performance reasons, I'm often at login time caching a user's access control rules inside of the session. I want to make sure that if I as administrator, if I change somebody's access control policy for a particular user, oh, that's a giant problem. Because what if I have an active JSON web token in play right now? Or what if the user's access control model is already cached in the session? So the point I'm trying to make is, whenever you as an administrator change someone's access control policy, you should also make sure you're invalidating existing JOTs for that user or forcing their session to refresh right away. So those new access control rules for that user, the entitlements, get reloaded from your admin change. This is rarely done well. Also, we want grouping. I showed you a data model earlier. Everything in that data model should be grouped in some way, because I would never grant a user, usually an individual entitlement. I'll usually add a user to a group and set the entitlement for that group, and that's usually enough for most security configuration needs. And so I want you to also, after this presentation, please go look at the Application Security Verification Standard. We're on version 4.01 with 4.02 coming out soon in the 4.0 line. Here you see granular access control security requirements that you can consider for your app design. So a lot of us do security a bit ad hoc. I'm recommending you do not do security ad hoc in your software, and instead use a standard for application security, like the Application Security Verification Standard. Check out that access control section in detail for other considerations in your design. A few final notes: best practices, right? Enforce access control in your code by the enforcement point by an activity, a feature name, not the role itself or anything policy driven. Implement data contextual access control in a standardized fashion like we just looked at. Number 3, build a centralized access control mechanism as opposed to it being scattered all over your code base. Number 4, make sure all requests are authorized. A filter is ideal for this kind of access control, for this kind of security need. Deny by default, fail security. If something goes wrong, don't give access, right? Make sure the right server-side data drives access control decisions. Enforce valid workflow paths and be careful of step skipping type attacks, which are real common in e-commerce. Be able to change a user's granting of permissions, granting user entitlements. Make sure if you change those rules as an admin, they take place right away. And make sure you have proper grouping so configuration is going to work out. Also consider reading the federal government standard on ABAC. This shows how a large organization should be pushing towards advanced access control. And it's really hard to get this right late in the life cycle. Many security problems, I can admittedly go back to that software and fix it. If you have a major design flaw in the world of access control, get ready for some very heavy lifting. This is something we want to work hard to get right up front. Something where threat modeling and design security processes are extremely effective. Here's some additional guidance. The OWASP access control cheat sheet. OWASP is the Open Web Application Security Project, by the way. And also the NIST standard on access control, NIST 800-162. It's a hard read. It's a great read. We'll set you in the right direction. All right. We're about done. We covered a lot of ground today, right? We talked about role-based access control as an enforcement point and why that's a problem. We looked at some attacks on access control. We looked at some anti-patterns, some best practices to lead you down the path towards claims-based security. It's harder work up front. It's more design, more heavy lifting. But later in the cycle of your software, you're going to thank me for this. And if you're a large organization, this is something you should have standard for all your developers. Anytime you're building new software and you tell developers, go figure out access control on your own, that's a bad thing. So typically for a big company, we want access control design solved. So this can be rolled out to our developers in an efficient manner, because access control in complex applications get really tough to do right and fast. I hope you had a good time in this talk. I sure did. I enjoy RSA. I'm grateful for RSA. And I know RSA has a lot of access control products. Check them out, right? Let's give a nod to RSA for kindly sponsoring this webinar. If you have questions for me or interested in application security training, I'm jim@manaco.com. I train developers for a living. What a pleasure it was for me to be here today. Thank you so much. We're done. I am happy to answer any questions if you're still here, folks.